Okay, so this video goes with the second half of packet 3. So with these pound ounce problems, they say convert everything to ounces, but basically if we remember that 1 pound equals 16 ounces, all we really have to do is add the number of pounds, add the number of ounces. With the ounces, take out multiples of 16. For each multiple of 16, we're going to add a pound, and then the remainder is going to give us the ounces that are left over. So I'll show you what I mean by that. So let's look at number 1. What's the combined weight of package 1 and package 4? So package 1 is 8 pounds 13 ounces, and package 4 is 9 pounds and 7 ounces. Well, between both of these we get 17 pounds, and with the ounces we get 20 ounces. Now if we take 16 off of that, we're left with 4, and we're going to carry 1 over because 16 ounces is a pound. That's going to give us 18 pounds and 4 ounces. So D is going to be the correct answer for number 1. Let's look at number 2. What's the combined weight of package 2 and package 3? 2 and 3, the pounds are 22, and the ounces give us 18. If we take 16 off of 18, we're left with 2. So we add 1 to the pounds because we took a 16 off, and we're left with 2. That's going to be 23 pounds, 2 ounces. So B is going to be the correct answer for that one. Let's look at B. Use the chart from activity A and the cost of shipping to answer these questions. Let me switch colors. What was the combined weight of the 4 packages? Okay, so we have to go back up and look. So the 4, let me get this out of the way. And we're going to add up all 4 of these, because what they're going to do is ship all 4 of these packages and see how much it's going to cost to ship them. So 8 and 15 is 23, and 7 is 30, and 9 is 39, so it's 39 pounds. Let's see how many total ounces. We got 23 ounces, 31 ounces, 38 ounces. So if we take 32 off, that's going to be like 2 pounds. So we're going to add 2 on to the 39. And that's going to give us 6 left over for the ounces. And we're going to have 41 pounds, 6 ounces. So B is going to be the correct answer for that one. And let's see. If DeMille wants to ship the packages to a location in Zone 4, what will be his total cost? It's going to cost him $4.60 per pound, and round up to the nearest pound. So we're going to round up to 42. So we're going to have to calculate 460 times 42, because we're rounded up to 42 pounds. 0, 12, carry the 1, that's a 9. 0, 24, carry the 2, that's an 18. We end up with 0, 2, 13. Looks like 193.20. So 193.20 is going to be the cost to ship these. Okay, let's look to the next page. So this deals with a rowing team, and there's a 500 meter, okay, each rower complete a 500, so each one of these is the times to row 500 meters. Let's change to red. What's the total time it took for the 4 rowers to finish the race? Now, with minutes and seconds, we have 1 minute equals 60 seconds. So that's going to be our conversion. So we're going to do pretty much the same thing here. We're going to add the seconds up take out multiples of 60. For each multiple of 60, we're going to add a minute. And then the odd seconds left over are going to be the remaining seconds. So we have minutes, we have 5, 10, 15, 21 minutes. Seconds, we have 52, 102, 107, 127, 130 seconds. So take two 60s off of that, add 2 minutes on, we're left with 10 seconds left over. So this is going to be 23 minutes, 10 seconds for number 1. For number 2, what's the total length of the race? We got 4 legs of 500 meters each. That's 2,000 meters, which is 2 kilometers. Which best approximates Xenia's speed in terms of meters per minute? So Xenia went 500 meters in almost 6 minutes, like 5 seconds less than 6 minutes. So we can just do 500 divided by 6 and see what we get. So 500 divided by 6, that's going to give us 8. It's just 48. 2 left over, that's going to give us 3. That's 18. 2 left over. So 83.33, but it's approximate. Closest one to it is going to be A, which is 85 meters per minute. Number 4, in meters per minute, which best approximates the average speed of the 4 rowers? Now, to get the average speed, we're going to take the total time that they took, which we saw was 23 minutes 10 seconds, so we're just going to count the 23 minutes, and they did 2,000 meters. So for that one, we're going to do 2,000 divided by 23. Okay, I don't have my calculator with me, so we got to do it the long way. So we got 2,000 divided by 23. Okay, let's see, 8, 160, 180 something. It's going to be, yes, 6. 6 times 3 is 18. Carry the 1. No, 12, 13. It's going to be 8 for that digit. 8 times 3 is 24. Carry the 2. 16, 18, 184. That's going to leave us with 16. Bring down the 0. And this is going to be almost 5. No, 6, 7. 7 would be 161. So close to 87. In meters per minute, which best approximates the average speed? 87. Let's move down. Let's see where we're at here. Let's move down. Okay, bus distance and time chart. Okay, let's see what's going on with this one now. About how many hours does it take the bus to travel the loop from Keaton to Schaumburg to Lorraine, then back to Keaton? And then what's the approximate speed of the bus? So let's see. How many hours does it take the bus to travel the loop from Keaton to Schaumburg to Lorraine, and then back to Keaton? So Keaton to Schaumburg. Let's see, maybe we can do it down here. Let me maybe blow this up a little bit more and move it up. I'm going to try to work it down here then. So Keaton, talk about how many hours it takes. So we're going to be dealing with the times columns here. So Keaton to Schaumburg. Keaton to Schaumburg is 440. Schaumburg to Lorraine. Schaumburg to Lorraine is 355. And then Lorraine back to Keaton, Keaton to Schaumburg, Schaumburg to Lorraine. Wait, Keaton to Schaumburg, 440. Schaumburg to Lorraine, Schaumburg to Lorraine is 355. And then Lorraine back to Keaton, Lorraine to Keaton is 235. So we add these up. We're done with time, so we're still going to take off multiples of 60. This gives us 95, 125, 130 in terms of seconds, or in terms of minutes. And this is hours now. Okay. Oh, now the difference is minutes and hours. Oh, yeah, 60 minutes is 1 hour. So same thing as the minutes and the seconds thing. So 4, 5, 6, 7, 9 hours and 130 minutes. Take off 2 60s. That's going to leave us with 10. And we're going to add 2 onto this. So 11 hours and 10 minutes is the approximate time it takes for that round trip. Okay, so 11 hours, 10 minutes. 11 hours, 10 minutes. What's the average speed? Now, what's the distance? Okay, so now we're going to do the distances, and speed is going to be in terms of miles per hour. So we need to get the total miles, then we're going to divide basically by like 11 and do the rounding. So the miles from Keaton to Schaumburg, 202. Let me change colors. So 202. Schaumburg to Lorraine, 160. And then Lorraine back to Keaton, Lorraine to Keaton, 103. So we get 5, 6, 2, 3, 465 miles. So to find the average speed in terms of miles per hour, we're going to do 465 miles divided by, and we're just going to use 11 hours. So 465 divided by 11. Okay, times 4 is going to be 44. 2 left over, 25. That's going to be 2. It's going to be 22 and 3/11. So just right around 42 hours, a little bit more than 42 hours. So say about 42 miles per hour, rather. So the average speed is about 42, maybe 43 miles per hour, and the number of hours it takes is about 11 hours and 10 minutes. Okay, so let's see. So we kind of estimated on these to make the numbers good, but that was probably the way to go with it. And that's really all there is to this part 2 then. Let me reduce this back down. And that's our final answer for these. So that's this last part of packet 2.